Okay. Um, Now this is the CKPJ parts analysis. First thing I had to do was to go to the folder and pull out the workbook named parts. After I pulled out the workbook named parts in chapter 2's folder, I now had to rename it by saving it as CKPJ parts analysis right here. Then we had to modify this data. Now you can see, now these are the days. Now the days are numbered all the way to 30 days. I had to freeze panel it, so that's why you could scroll down and the title still remains the same. The customers number are from 2010 all the way to 2696, and these are all the samples for the 30-day period. Now we were requested to find the high limits and the low limits for each customer, which you can see right here. This is the equation for the high limit, that's the max of the range. For the low limits, that's the minimum of the range, and I had to do it for each customer. So you can see that you could just autofill and you would get the high and the low limits. Now the next thing we were asked to do was to do a simulation. So we had to create another worksheet called simulation right here. We took the data of the simulation and the highest and the lowest for all the customers, and we were requested to create 100 instances for this simulation. Now I was confused at first, but later on it just came to me, bam, and I was like, okay, that for a simulation, the equation, we had to use a Randbetwen, a random between two columns or two ranges. Now the two ranges we were given was the highs and the lows. Well, that's why they asked us to look for the highs and the lows. So the random between the two variables, the highest, the bottom, and the low. And this is what I got right here. But we had to do it for 100 instances. So I had to create 100 instances of highs and lows, random data. You can see right here. You can see that I also freeze the panel right here. And when you go up and down, you can see it right here for 100 days. Now we were supposed to copy this data, this simulation that we just created for each customer for 100 days instances, and create another workbook sheet called simulation data. Now you go into the simulation data. Now this is where the whole lump sum of work was put in this simulation data one. Now you can see that the data, we still have our simulation data for the 100 instances for the for 30 days, right? So now we were requested to find the total demand. Now the total demand for all the customers on one day. Now you can see right here that it was a sum of B4 all the way to K4 for all the customers. Now after doing that, the total demand for all the customers, we had to do it for the 100 days right there, right? And we went all the way down and got our results. Now we were requested to find the mean, the average for every customer, for the sum of the customers, which we got. The average was 7 for the whole 100 instances, which we came down and we got our results. Now we were asked to find the mode, and this is the equation for the mode. This is the equation for the average. This is the equation for the sum that I did. The mode was right here, and we were requested to do the median, which you can see. This is the equation for the median right here, and the standard deviation. This is the equation for the standard deviation. After we did this and we auto-filled everything down, we were requested to do a rank. Now the rank of the total demand, and this is the equation for the rank for the total demand. Now you can see that every time I press F9, because it's a random stimulation equation, it changes. All our results changes because it's random. F9 brings out random, and it gives us a different total demand, total mean, different total mean, total mode, median, standard deviation is total, and the rankings switch up too. You could say twerk, switch up. Then we come over here, and we were requested to do the top 5 and the bottom 5 lowest. Now the top 5 for each customer, you can see that for this equation right here, it's a large that I used, and it was based on of each customer. You can see right here, B4 all the way down, and arrow 1. That's the rankings for the stimulation. Now you can see, but you can also notice every time I press F9 right here, you see that the ranking still remains the same because it's a rank. It ranks the highest to the lowest. It still remains the same, even for the lowest too. That's the equation for the 5 bottom lowest. You can see the 5 bottom lowest is from 1, 2, 3, 0, and after I press F9, it still did not change. It remains the same, 1, 2, 3, 4, 5 for every customer. Now we were requested to do a bearing recommended per day for 5 days, and you can see the bearing recommended for the first day was 23, second day 19, 16, third day 16, fourth day 20, and the fifth day 20. Now if I twerk it, or if I just hit the F9 button, we get this results right here. This is recommended for the bearings. Now we were asked to go to another worksheet in the chapter 2 folder called demand, and pull that out and create in our own CKG part analysis a worksheet named actual demand. So we copy pasted all the data from that from the demand worksheet into our CKG part analysis, and this is what we got: the description, values, and days. I froze the panel so you can see how much data we have over here. It's up to close to 992, close to 1,000 data. Now we were requested to find out a summary. This is actually the summary. Now you can see the bearings right here, and we will actually find the number of items shipped from this data. So we had to use the Countif. So the Countif would go in here and pull out all the bearings, number of bearings that we have, and give us a count for each bearings and the count for each timing belt. You can see the equation for the timing belt. You can notice that I used this right here called a wildcard for T. You know, it brings out every item that starts with a T. This brings out every item that starts with a B. It brings out every item that starts with an A, and it counts every item that starts with an F, and counts on every item that starts with an E. And we had our counts right here. Now we were told to do the total dollar value of each item right there. So we had to now use a Sumif function. A Sumif function with a criteria of a wildcard that says, give me the total of every bearing of every item that starts with a B. That's a bearing. Give me the, then we'll do the second one, give me a total of every item that starts with a T, and give me every total of items that start with an A, and give me every total of an item that starts with an F, and give me a total of an item that starts with an E. Then we go and we were requested to find the average. Boom. Now we have to use the AverageIf because we had to go for every item to find the average of every item that starts with a B, to find every item, the average of every item that starts with a T, to find out the average of every item held in the inventory. Remind you, held in the inventory that starts with A, every item held in inventory that starts with an F, every item in the inventory that starts with an E. Now, based on my recommendation, you can see that average is 20, 21, 21, 20, 22, 22, 21, 21, 21. That was from complete, this data right here is completely from a worksheet that was entirely completely different from our simulation. And then we go back to our simulation and we can see that the numbers F9, these are the requirements of items held in the inventory based on our simulations. Now, is this very similar? You can see 22, 19, 17, 18, 19, 16. Is it very similar to this simulation right here? This actual average that they already have. So my conclusion was that my calculation was enough to cover these orders. Thank you, and please go down and click like and make some comments too. Thank you.